this lesson, we're going to learn about matrix multiplication. Before you learn how to multiply two matrices together, I'm going to show you a little trick to get you started. So, if we were to multiply a matrix with a dimension of 2 by 2 with a matrix of a dimension of 2 by 3, we want to know just by looking at the dimensions if we're going to be able to perform matrix multiplication. So the way that we're going to check for this is by looking at the inside numbers. If the inside numbers are the same, which they are, that means that when I go to perform matrix multiplication, the dimensions are going to match up and I'll have enough elements in each row and column of the matrices in order to perform the multiplication. Now when this happens, when I have the two numbers on the inside that match, the two numbers that are on the outside are going to tell me the size of the matrix in my solution. So if I were to multiply a 2 by 2 matrix with a 2 by 3 matrix, my solution would be of dimension 2 by 3. Another example of this, a counter example, would be if I were to multiply a 2 by 3 matrix with another 2 by 3 matrix. Checking the inside numbers, these two numbers are not the same. This means that my dimensions do not match. So if I go to multiply, I will not have the correct number of elements to match up in each matrix. This multiplication of a 2 by 3 matrix and a 2 by 3 matrix is not possible, so we would have no solution for our product. Let's try some examples. For my first example, I'm going to be finding the product of multiplying matrix A and matrix B together. So I have matrix A and matrix B. Matrix A is a 2 by 2 matrix and matrix B is a 2 by 3 matrix. Looking at the dimensions, my inside numbers are a match, which means I will be able to perform this multiplication. When I perform the matrix multiplication of matrix A and matrix B, my product is going to be a 2 by 3 matrix. So what I'm going to do first, just as an organizational method to help myself along the way, is draw out what a 2 by 3 matrix will look like. A 2 by 3 matrix has 2 elements in the column and 3 elements in the row. So my solution after multiplying matrix A and matrix B will look something like this 2 by 3 matrix that I have drawn out right now. So let me show you how we can find the product of matrix A and matrix B. First thing we're going to do is take the row of the first matrix and the first column of our second matrix, and we are going to multiply the elements together, beginning with the first element, which is 7 and 3. 7 times 3 gives me 21, and then we go for our second element. 0 times 5 is 0. When we add 21 and 0 together, we are going to get the first element in our solution matrix, which is 21. We are going to repeat this process of row times column, but now we have already used the first row with the first column. So now we are going to use the first row with the second column. 7 times negative 3 is negative 21. 0 times 4 is 0. When I add these two values together, the second element in the top row of my solution matrix is negative 21. Now that I've used the second column of my second matrix, I need to continue on my multiplication with the third column. Again, I'm going to utilize the first row of my first matrix with the last column of my second matrix. 7 times 6 is 42, and 0 times negative 2 is 0. Adding 42 and 0 gives me the final element in the top row of my solution matrix, which is 42. Now, as you can see by the model that I began filling in, we've now filled in the top row of our solution matrix, which is going to be a 2 by 3. So we have 21, negative 21, and 42 at the top. What we did was we distributed the entire first row of my first matrix with each column of my second matrix. The next thing I'm going to do is utilize the bottom row of my first matrix. I have not used the elements 5 and 3 to perform multiplication. So that's what I want to do next. And what we're going to do is, using that bottom row with the 5 and the 3, we are going to make sure that this bottom row gets multiplied to each column of my second matrix. So, beginning with bottom row, first column, 5 times 3 is 15, and 3 times 5 is 15. Adding those two elements together, I get 30. I've now utilized the first column of the second matrix. So now I'm going to move on to the second column, multiplying 5 and 3 by the second column in matrix B. 5 times negative 3 is negative 15, and 3 times 4 is 12. Adding these two elements together will give me negative 3. Next, I'm going to use the final column of my matrix, multiplying that with still the bottom row of my first matrix. And what I have is 5 times 6 is 30. 3 times negative 2 is negative 6. Adding these two numbers together, the final element in my matrix is 24. So the product of matrix A and matrix B is the 2 by 3 matrix that I have circled in yellow. Example number 2, we have another 2 by 2 matrix, which we are going to multiply with a 2 by 3 matrix, just as the last example. We'll check again. The inside numbers are the same, so we know our dimensions are going to match when it's time to multiply the two matrices together. And for our solution, we will have a 2 by 3 matrix, which I will now draw out. 2 by 3 matrix again is 2 elements in each column, followed by 3 elements in each row. So this is a model of what our final solution will look like as a 2 by 3 matrix as we find the product. So remember that we are always going to begin with the top row of the first matrix, and we want to go through and multiply this top row with each column in my second matrix. So, starting with the first row and the first column, I'm going to multiply 7 times 6, which is 42, and 0 times 2, which gives me 0. And when I add those two elements together, the first element in my solution is 42. That takes care of the first column, so now I'll move on to the second column, and still using my top row, 7 times -1 is -7, and 0 times -2 is 0. Adding those together gives me a second element of -7. We've now used the second column in our matrix, so we will finish by using the last column of the matrix with the first row of my first matrix. 7 times 4 is 28, and 0 times -1 is 0. So the final element in my top row is 28. Now that I have completely used the top row with each column of the second matrix, I now need to start over. This time I'm going to be using the bottom row with each column of my matrix. So starting with the first column, we have 5 times 6 is 30, and 3 times 2 is 6. So the first element in my bottom row is 36. Now we'll use the second column, keeping with my bottom row. 5 times -1 is -5. 3 times -2 is -6. Adding those together gives me -11. And lastly, I will use my third and final column. First, 5 times 4 is 20. 3 times -1 is -3, making the last element in my matrix 17. Now that I've used each row of the first matrix with each column in my second matrix, my final matrix is a 2x3 matrix with the elements that you see here circled in yellow. Our third and final example for today, we have a 2x3 matrix being multiplied by another 2x3 matrix. You should notice right away the inside values for each dimension do not match. Because these numbers are the same, I will not have enough elements to multiply the first row or the second row by each of my columns because of these mismatched numbers. Therefore, example number 3 is not possible, and we will not be able to perform matrix multiplication.